Hello and welcome. In this video, we are going to solve question number 11 of Leetcode, that is container with most water. So let's first read out the statement. So we are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I of I and height I. We have to find two lines that together with x-axis form a container such that the container contain most water. So we have to find out the maximum water that can be stored in between any two walls. So these are the height of walls that we have already given. So you can see that height of first wall is 1 and second is 8. So maximum water between these two wall is going to be minimum of height, that is minimum of height I and height j into width between these two walls. So for this condition, width is going to be 1. So you can see that maximum water that can be stored in between these two walls is going to be 1 into 8. 1 into 1, that is going to be 1. So if we will consider this any two walls for a second, like wall 8 and wall 8. In this case, width is going to be 1, 2, 3, 4, 5. So in this case, minimum is going to be 8 and the width is 5. So water is going to be 40 in it. Okay. So we can say that maximum water that can be stored in between any two walls is going to be minimum of height I into height j into the width, the current width. Okay. So how you can find out the maximum water in all given heights? So for that we have to check all the pair. How you can find out all the pairs? So for that we will be using for loop. So we will be iterating from I equal to 0 to n at initially, and inside this there will be another for loop of j equal to I plus 1 to n, and then we will be finding our result, which is going to be the max of result and the current water, that is going to be mean of height I and height j into width. So width is going to be j minus I. Okay, so this is the current result, and we have to check all the cases. You can see that this is going to run total n square of time. So time complexity for this case is going to be big of n square, and the space complexity is big of 1. So can we optimize this? Let's see how we can. So our goal is to find out the maximum water. Can we do can we use any other approach like two pointer or something? How we can use that? So we are going to use two pointer in this. So as our goal is to find the maximum water, we will be placing our one pointer at the beginning and one pointer at the end. So this is going to be give maximum width, and we have to find the maximum height of between two walls. So initially I is 1, I at 0 index, I at 0 index, the height of I is 1 and height of j is 7. So the water that can be stored in between is going to be minimum of 1 and 7 is going to be 1 into width is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so currently result is 8. Again we will find out. Okay, now we have to shift our pointer either leftward or rightward. So which one will be better? So as you can see that minimum value is at index 0, so we will be shifting it at left right side. Okay, so for now I is at index 1 and j is at index 7. So width between these two is j is at index 8. So width between these two is going to be j minus I equal to 7, and the minimum between these two height is going to be 49. Minimum between these two is going to be 7. So our current result is going to be 7 into 7 equal to 49. So we'll be updating our result, and then we'll move either of one pointer. So we can see that minimum pointer is at index j. So we'll be moving j leftward, our current value of j is going to be 7 and I is 1. So width between these two is j minus I equal to 6, and the minimum value is 3. So 3 into 6 is going to be 18, which is lesser than our current value, that is 49. So we can see that again we have to move our j. So our current j is at index 5 and I at 1. So j minus I, that is width, is going to be equal to 4. Width is going to be equal to, so 6 minus 1 is, that is going to be equal to 5, and the minimum value between these two is 8, as both are equal. So in this case 8 into 5 is going to equal to 40. This is still lesser than our current result, so we'll be moving either of one pointer. As these two are equal, we can move any of these two. So we are moving the j, then j is at index 5, current width is 4, and minimum value between these two wall is 4. 4 into 4, that is 16. We can iterate all the cases, but we will find out that now none of the case is going to be greater than 49. So now we have to write the pseudocode for the same. How we can write this? Let's see. First we have to initialize our result as 0, and we will be pointing I at index 0 and j at index n minus 1. Okay, we will be iterating our while loop while I lesser than j, and in every step we will be calculating our result, which is going to be equal to max of result and width, that is going to be equal to j minus I into height of j, minimum of height of I and minimum of height of j. So this is going to calculate our result, and we'll then after we'll check whether height of I is lesser than height of j. Which one will be lesser, we will be moving that. So if height of I lesser than height of j, then we will be moving up our I in right side. Otherwise, in else case, we will be moving our j in right side, and at last we will be returning our result. Okay, so this is the pseudocode that we will be writing in our compiler. So let's go to the compiler and write the code for the same. So yeah, int result is 0 and I equal to 0 and j equal to height dot length minus 1. We will be moving our while loop until I lesser than j, and it in every step we will be calculating our result, which is going to be equal to math.max result and j minus I, that is the width between these two indexes, and into math.min, minimum height between these two walls. So height of I and height of j. Okay, now we'll be checking whether our height of I is lesser than height of j. In this case, we will be moving our I into right side, else we will be moving our j into left side, and at last we will be returning our result. Now run this. Yeah, so first test case has been passed. Now submit this. So our solution has been accepted. I hope you must have learned something from this video. In this case, please like the video and subscribe to the channel. Thank you.